Hi everyone, welcome back to Data to Crunch. Today we will work on another case study which is based on supply chain analytics, which mainly focuses on Snowflake capabilities. Before we begin, a quick note. Flowbridge International Limited is a completely fictional company which is created for educational and demonstration purpose only. All the company names, customer names, supplier names, revenue figures, KPI values, stockout numbers, and business matrices, whatever is mentioned throughout this presentation and the project, those all are fabricated. They do not represent any real company, real financial data, or real business performances. However, the scenarios we will cover throughout, for example, supply chain pain points, data quality issues, then pipeline architecture decisions, all these are based on real patterns you would encounter in an actual enterprise data engineering projects. But the specific numbers and the names, those all are fictional. So this is a learning project, and the goal here is to teach you a real engineering skills using realistic but entirely made up scenarios. With that said, let me introduce you to the Flowbridge International Limited. So this is a global industrial process equipment distributing company which is headquartered in Chicago. They generate 420 million in annual revenue and they operate 5 warehouses across 3 regions. Chicago and Dallas in North America, then Frankfurt and London in Europe, and then Singapore in Asia Pacific. Along with that, they distribute 3 categories of industrial equipments. First is electronics like industrial sensors and the pressure gauges, then electrical like control panel and the circuit breakers, and then the lastly mechanical like hydraulic pumps and safety valves. With that, they have 6 enterprise clients as their customers: Logiflow Supplies and Global Trade in North America, then SwiftMove and Eurologistic in Europe, then Prime Parts and Asia Pac in Asia Pacific. With this, they have 5 suppliers as Tech Parts in USA, then Fast Supply in Germany, Asia MFG in China, then QuickShip in UK, and then the Global Parts in France. So overall, they have five warehouses, then 6 customers, 5 suppliers, and orders. Those all flow across these 3 continents every single day. And yet, their analytics infrastructure is completely broken. And let me show you why. So every Monday morning, Flowbridge analyst manually exports their data and then sends it to their 3 logistic partners. So till then, 7 days are already passed before those partners even see that data. So this is the core problem and it shows up across 6 specific pain points. The one is specifically weekly batch reports. So by the time supplier issue appears in their weekly report, it is already 7 to 10 days old. So till then, 200 delayed orders are already shipped. So the damage is already done before anyone knows even there was a problem. Then they have manual JSON file processing. So 3 analysts spends their 12 hours of every week just for compiling and sending those data files. So this is like 12 hours of skilled analyst times, which is spent on a task which an automated pipeline can do in seconds. Then they have no real-time inventory visibility. So nobody knows which warehouse is running low on stock until it is too late. So this result is like 47 stockouts per year costing, which costs Flowbridge 2.3 million annually. Then they have no supplier scorecards. So there is no visibility into which supplier is underperforming until it shows up in their weekly reports. So by then, business has already taken a hit. They have delayed shipments. Then because of that, they have unhappy customers and they have lost the revenue. Then they have manual partner data sharing. So logistic partners are making their operational decisions based on the data that is days old. So they cannot plan accurately because they never have their current information. And lastly, they have zero pipeline monitoring. So when something breaks down in their data pipeline, nobody knows. So business users discover those failures first when their reports look wrong. And because of that, engineers they find it out last. So there is like no proactive alerting for this system. So this is the before state, and this is exactly the problem we are going to solve. So for that, Flowbridge has decided to partner with Data2Crunch to build real-time supply chain analytics platform on Snowflake, which will cover ingestion, transformation, aggregation, governance, and a live dashboard. So this is a full engagement of 14 weeks covering all the data engineering practices. And in this tutorial series, we will cover a complete engineering delivery, every object, every script, every design decision, which is built from the scratch. So for this project, we will be utilizing Azure Cloud Storage to store our initial data, and then we will utilize Snowflake to create our data pipeline. So this will raise one important context point. As Flowbridge is our small to mid-sized company, they are not able to afford enterprise ERP systems like SAP or Oracle because it would cost much more just for licensing, and then we also have years of implementation type, right? And simply Flowbridge doesn't have that one. So for that sake, we will be utilizing Azure Cloud Storage instead, okay? So this raises one important question. How does data get from Flowbridge's operations into our cloud storage, okay? So there are multiple ways to solve this. So one common approach is using Azure Data Factory, which is fully managed ETL service that connects directly to source systems or databases and APIs, and it loads our data into ADLS Gen2 on schedule or in real time. So this is what many mid-sized companies use when they have structured databases and they are not using or utilizing ERP. For this project, what we will do, we will utilize Python scripts that simulates exactly like a source system by generating realistic JSON files and then uploading them into ADLS Gen2. So if we say why to choose this approach, we have two reasons. So first one is that it keeps our project mainly focused on Snowflake and the creation of data pipeline within Snowflake, okay? Rather than focusing on source system and how to perform that data integration. Then secondly, it will give us the full control over the data. So with this Python script, we will be creating or generating data that will basically it will have clean data, messed up data, bad records. So it will have full control over the data mix so that you can see exactly how each one of the data quality rules or validation rule behave in our data pipeline, okay? So in real project, you would replace Python scripts with whatever source your system supports. For example, a direct API push or Azure Data Factory or an ARP export or a Kafka stream. So Snowflake pipeline, which we will build, it works exactly the same way regardless of how data lands into ADLS Gen2, okay? So the next important point is that why JSON and why not CSV? So we all know that CSV is a structured, flat, easy to work with data. Okay, so most of us have opened CSV file in Excel at some point. It has headers, rows, and columns. Very straightforward to load and query. Okay, but in real time, most modern source systems, for example, APIs or mobile applications, ERP exports, or IoT devices, they often produce JSON data. And JSON data is fundamentally different. It is nested, it has hierarchies. A single JSON record can contain objects within objects or array within objects and varying structure from record to record. Okay. So this is the exact reason it makes it challenging and exactly why it is worth learning. So in this project, we are intentionally working with nested JSON because this is what you will encounter in real enterprise pipelines. So we will store that data as a raw files, or we will store that raw data as a variant in Snowflake. Then we will see how we can flatten it, how we can perform data validations, how we can clean that data, and then the transformation in the upcoming part. Okay. So by the end of this project, you will know exactly how to take complex nested JSON structure and then turn into clean, queryable, analytics ready tables in Snowflake. So this is the skill that transfers directly to any real world data engineering role. This is how our data pipeline architecture looks like. So for this project, we will be utilizing two environments, development and production. First step here is of data generation. So we will be using Python script with Faker library to simulate our FlowBridge source system. It will generate realistic supply chain JSON file and then it will upload them into Azure ADLS Gen2. We will be utilizing two modes here, historical and continuous. Under historical mode, we will upload three files at one time with 100 records each. So this will be our one-time ingestion. Then under continuous mode, we will keep uploading files at the interval of 30 seconds to 1 minute with 100 records in each file. Then we will have two separate containers under Azure ADLS Gen2, one for development and another one for production. So we are keeping these containers individual in order to keep our environments completely isolated. Then we have Snowpipe for ingestion. So here Azure Event Grid, it detects the new file at the moment it arrives into our storage account. And then it sends it sends notification to our Azure storage queue. Afterwards, this Snowpipe, it will read that queue and automatically it will ingest that file into our Snowflake within few seconds. Hence, we can say that this is fully event driven and we are not utilizing any cron jobs or nothing manual will happen here. Now we are into our Snowflake where we will create our data pipeline and we will use medallion architecture in order to perform data cleaning and transformation part. First is bronze layer. Under this bronze layer, we will create one transient table that will store our raw JSON exactly as it has arrived. That means as a variant column. So no transformation will happen here and we are maintaining this in order to keep our audit trail. Hence we can say that this is our raw landing zone. Then under silver we have two stages, stage 1 and stage 2. Under stage 1, first we will create stream on top of this transient table. Hence that stream will track every new record that Snowpipe will load in that transient table. Then once we get some data into stream, it will trigger one task and then that task will trigger one stored procedure. Now into that stored procedure, we will write our code for our data cleaning. For example, flattening of JSON, validation of every field, or maybe auto cleaning of messy records. And then we will route our genuinely bad records into dead letter standard table. Afterwards, whatever we are left with, clean and fixable records, those records will go under this another transient table. Now, under this stage 2, we will utilize these entries and we will perform data modeling. So for this, we will create one star schema. Again, under stage 2, we are creating stream. If we have data into that stream, then we will trigger one task and that task will trigger one stored procedure. And now in this stored procedure, we will write our code for data modeling. So this stored procedure, it will perform 5 dimension merges and one fact dimension merge in order to build and maintain this star schema. So our dimension tables would be dim customer, dim product, dim supplier, dim warehouse, dim shipment, and we will have one fact order fact table. Here we are going to use surrogate keys, which will be generated by sequences. Then we will have gold layer, and under this gold layer, we will be creating dynamic tables. So our first dynamic table would be aggregation base table that will join all the necessary silver table once with the lag of 1 minute. It will be followed by 4 downstream KPI tables. And those tables would be aggregation order fulfillment table, then aggregation supplier performance, then aggregation inventory turnover, and lastly aggregation shipment delays. And all these 4 dynamic tables, those will get refreshed automatically when aggregation base table will get refreshed. Hence, Here we are not going to need any extra task and procedure because Snowflake is going to manage all of this when we use dynamic tables. Last layer is our serving layer. Under this serving layer, we will be creating 4 secure views which will sit on top of this gold dynamic table. And these 4 views will be accessible to analysts and partners via data sharing. When we create secure views, partners will be able to query and access that data, but they will never be able to see SQL definitions which are behind it. So those SQL definitions will be hidden, and hence we can say that our all data will be governed. Then under the outputs, along with this data sharing, we will be creating one dashboard. So this will be our Streamlit dashboard created under Streamlit app. Now the legacy dashboards which we used to create under Snowflake, those will get depreciated by June 2026, and those are replaced by Streamlit app. So we will be utilizing this Streamlit app in order to create this dashboard from Snowsight. And it will show our live KPIs with 60-second refreshed cache. So once we are done with this, under the monitoring section, we will be creating one health alert, like pipeline health alert, which will run after every 5 minutes, and it will monitor our Snowpipe failures, then task failures, and then dynamic table refresh failures. So any one of these failure will occur. This monitoring pipeline, it will trigger one email notification to that respective data engineer, and then once that data engineer gets that notification, he will look into this data pipeline and will figure out what's exactly going wrong instead of monitoring this pipeline by 24 by 7 manually. Afterwards, our all code will get versioned by GitHub. Okay, so we will have development branch for dev. Then we will have main branch. We will treat that main branch as production. So development will get promoted to production via zero copy cloning. And we will see how we can use this zero copy clone instantly with no data movement. And under this, some task will get or some objects will get will be needed to be recreated, and we will also check that which task we need to recreate and which task we can just clone with zero copy cloning with no data movement. So this is how our complete data pipeline architecture looks like. We will
Now,
discuss our 5 key design decisions that make our pipeline production grade. First is to use automated JSON ingestion via Snowpipe. So as discussed just now, JSON files will keep arriving at the interval of 30 seconds. Then Azure Event Grid, it will detect each file instantly, and then it will trigger Snowpipe automatically via storage queue. This means that there is no human intervention is involved. We don't have any scheduled jobs or no polling. This pipeline, it will react to the data arriving. So it will not basically wait for the clock to tick. Then we have decided to use 3-stage conveyor belt ETL. So every record, it will go through these 3 stages. Then the messy records, for example, wrong date formats or extra white spaces or wrong casing, those will get cleaned automatically and will get passed forward. And genuinely bad records, for example, missing IDs, negative amounts, invalid dates, those will get rejected to the dead letter table. So nothing is silently dropped. And this dead letter is kind of a feedback mechanism. And operation team, it reviews it daily and it uses the pattern to fix the data entry at the point of source. Then we decided to use dynamic tables with downstream patterns. So we have aggregation based table that joins all the necessary silver data once. And we have 4 downstream KPI tables that inherit its refresh automatically. This means that our silver will get queried once and not 4 times. So the result is half the compute cost compared to running 4 hour independent aggregation jobs. And because all the KPIs derive from this base table, they are always consistent with each other. Then our fourth decision is to use zero copy clone for development to production. So the entire development environment will get promoted to production under few seconds using this Snowflake zero copy cloning. So no data is physically moved, no scripts are rewritten or rerun, then no risk of environment drift is there. So this is enterprise grade promotion pattern which is fast, safe and reproducible. And our last decision is to use secure data sharing for partners. So our three logic partners, they will query our live KPI directly from our Snowflake account via secure data sharing. Hence, there is no file transfer, no email attachments, or no stale snapshots. Data is always current because partners are querying our live secure views directly. So here there is zero copy, zero latency, and zero manual work. This is how your Streamlit app or dashboard will look like. This is our dashboard title. Then we'll give refresh data button if in case you just don't want to wait till that data gets reflected into your dashboard. Then we'll have filter by section. You can filter by either order date or ingestion date. Then we'll have time period drop down section. Here, if you can see, we have given options as today, this week, last 7, 14, 90 days, YTD last year, all time and custom range. Then we have order status filter. Here you can select either of the order. If in case you would like to select more statuses, then it will also give you that option. You can go ahead and choose multiple options here. Then we have custom region filter. You can select any of the region or you can select all the regions. If you select North America and if in case you would like to check for North America plus Europe, you have that liberty too. If in case you don't want it, then simply erase these statuses and regions and you can check for all order statuses and all customer regions. Then we have 4 matrices that will get displayed here. One for total orders, then total revenue, fulfillment rate and on-time rate. Afterwards, if you can see, we have given 3 tabs, namely trends, breakdown and suppliers. Under trends, we are showing 3 timeline series. One would be for daily orders. Here we will display daily orders by order day. Then we have daily revenue. Here we are displaying daily revenue by order day. And then we'll show average delay days. You can see here we are giving average delay by order day. So this will be our first tab of trends where we'll show time series. Then under breakdown, if you'll select this tab, you can see these bar charts. First bar chart would be for orders by region. Here we can see total orders by customer region, then revenue by carrier. Then we'll have on time versus delayed by carrier. Here we can see we have carriers and we can see that here we have this section for on time shipments and the above section for delayed shipments. And then we have inventory turnover by category. Here you can see all these 3 categories and respective inventory turnover ratio for the same. Then we'll have third tab as suppliers. We'll be able to see supplier scorecard. Here you can see your supplier name, their respective country, their respective total order, performance scores, and so on. Then we are showing performance score versus on-time rate. Here you can see respective supplier name, their on-time rate percentage, and average performance score. Okay, so this is how our Streamlit app will look like, and whatever filters we will apply here, according to that, all these 3 tab values will get changed. Okay, we'll see practically how we are going to implement that. Now let's move on to the next part. Now we will discuss about the transformation part that will happen under Silver Stage 2 layer. This is how our raw JSON source file looks like, and this is how our star schema will look like. So the raw JSON file that arrives from Flowbridge source system, that is deeply nested, and we can see that. So every order has customer object, supplier object, shipment object, items array, financial object, and lastly warehouse object. So all is nested inside one single JSON record. This nested structure is good for the source system, but it is very terrible for the analytics purpose. It is not easy to easily aggregate across these nested fields, or it's not easy to join them efficiently, or you cannot build KPIs you cannot build KPIs very cleanly. So for that purpose, we need to perform data transformation. And with this transformation, we are going to transform this all raw data into star schema, which is our industry standard for analytical data modeling. Under this, we are going to create 5-dimension tables that will capture our descriptive contexts like who ordered it, what was ordered, who supplied it, from which warehouse it got shipped, and how it was shipped. Along with these 5-dimensional tables, we have one fact dimension named as fact orders, which sits at the center with 5 foreign keys with which you can link to all 5 dimensions. And along with that, we have 6 measures, which are quantity, unit price, total amount, delay days, inventory level, and payment status. Every dimension and fact, it is going to use surrogate keys which are generated via sequences rather than using natural keys from the source. So these are going to be our surrogate keys for each table, and it will protect our warehouse from upstream ID changes. Okay. So this is how our data modeling looks like, and this is the foundation everything else is built on. So get the star schema right, and every layer above it becomes very simpler. Now moving forward, now let's discuss about data quality. This data quality is one of the most important and most overlooked part in any real pipeline. Let me show you how are we exactly handling it. So we have data mix at our source system with 70% approx clean data, then 20% approx messy data, and 10% approx genuinely bad records. Our pipeline is designed to handle all of these three with no manual intervention except for truly unrecoverable records. Stage 1 is reject truly bad records. So if a record is missing its order ID, customer ID, supplier ID, or product ID, we are going to reject it. If any order date cannot be passed through our expected date format, then we are going to reject it. If order status is not in the allowed list, we will reject it. If amounts are negative or quantity is zero, we will reject it. So each rejected record that will land into dead letter table with reason tag explaining exactly why it has failed. Then stage 2, auto cleaning of messy records. For example, if we have wrong date format, then we will automatically convert it. If we have extra white spaces in names or locations, we will automatically trim it. If we have wrong casing, we will automatically upcase it. If we have null carrier or location, we will default it to unknown. So these records are recoverable and they get recovered automatically. Then we have stage 3 where we will pass our clean records. So records that pass all these validations, they will go to STG orders tables, and then we will create star schema out of it. Here, the most important part of this design is this feedback loop. So the Flowbridge operations teams, they review this dead letter table daily. They look at the rejection patterns, why it is failing consistently, from which orders, from which suppliers, which time periods. They will examine everything. Then they will feed that back to the fixed data entry at our source. And by doing this over the time period, our pipeline gets the cleaner records because bad data patterns are caught and they are prevented to go upstream. So this is how this data quality will function. Now going forward, this is how our before and after scenario looks like. So before everything was manual and delayed. And this is how afterward scenario will look like once we create pipeline and automate everything. So earlier report freshness was weekly. So data was always 7 days old by the time anyone sees it. Analysts used to spend 12 hours a week for our manual reporting. Supplier issues used to take 7 to 10 days to detect exactly what has happened. Then business suffered 47 stockouts per year. Partners received stale data via manual file transfers, and there was zero pipeline monitoring, because of which failures were discovered by the business user and not by the engineers. But once we create our data pipeline, everything is going to change. Report freshness will be around now 1 to 2 minutes, which is 100x faster than weekly. Analyst reporting time would be 0 hours per week because we are going to automate everything. Supplier issues will get detected within few minutes, which is 99x faster. Stockout incidents has been dropped drastically from 47 to 11, which is like around 77% of reduction. Partners now query live data directly via Snowflake data sharing. Hence, we can say that there is no file transfers and no delays. Then we have pipeline monitoring that runs 24 by 7 with automated alerts, because of which now engineers will know first about the failures before business user will get to know about it. Hence, in the bottom line, we can say that around 2.3 million in annual stockout cost has been reduced. Then around $53,000 in analyst time would be saved every year. And supply chain team now can finally make decisions which are real-time based. This will be our complete tech stack. Azure ADLS Gen2 will be our landing zone, and it will handle our large-scale file ingestion at lower cost with the native integration to both Azure Event Grid and Snowflake. Then Snowflake will be our core platform, which will handle data warehousing, orchestration, transformation, serving layer, and governance all in one. Hence, will not need any separate scheduler or transformation tool or any separate BI layer to perform these activities. Then Snowpipe plus Azure Event Grid and Storage Queue. It will handle our ingestion part and it will be fully event driven. Files will land and those will be ingested within few seconds because of this Snowpipe, Event Grid, and Queue. Then we'll have Snowflake streams and tasks. This section will handle our orchestration part. Change data capture is built into Snowflake natively, hence we'll not need any external scheduler to perform orchestration activity. Afterwards, we have Snowflake stored procedure. It will handle our transformation part. So complex validations or star schema logic that will get encapsulated into testable and reusable procedures that can be called independently or by the tasks. Then we have Snowflake dynamic table. It will handle our aggregation part. Snowflake manages their refresh schedule automatically by using downstream patterns. Hence, no extra orchestration will be needed here. Afterwards, Snowflake secure views. These will handle our serving part. Analysts and partners will be able to query these views without seeing any underlying tables. Then we have Streamlit app in Snowflake that will handle our business intelligence part to create our dashboard. So no external server or no deployment. There will not be any separate authentication. It will run natively into Snowsite using the same session and the same roles. Snowflake alerts and data sharing. It will handle our governance part. Proactive pipeline monitoring plus zero copy partner access, both will be managed inside Snowflake. Then GitHub will handle our version control part, featuring branches, dev branches, main branches, everything will look into GitHub. So every change which we will do under this project, that will get tracked. And lastly, Python with Faker and Azure SDK, it will simulate our FlowBridge ERP system for this project. And in production, this would be replaced by actual source system export part. Okay. So this is how our complete tech stack looks like. Now let's move on to our practical part and start with our coding. This is my VS Code. I hope you guys have VS Code installed onto your PC. If in case you don't have it, then check the process of how to install VS Code. It is pretty straightforward. Before this, what we will do, come to this website, python.org.org/downloads, and then we will download the latest version of Pythons for our Windows. Okay. We'll come down, we'll look for specific release of 3.13.13. Click on it. Then here you will see files for Mac OS and Windows. In my case, it is Windows installer 64-bit. I'll just click on it and it will install that. Sorry, it will download that. Wait few seconds and you can see that downloaded file into your download section. Click on it. It will give you pop-up for install Python 3.13.13. Make sure to select both of these checkboxes. One is for add python.exe to your path and another one for use admin privileges when installing py.exe. Once you select both these checkboxes, click on install now. It will take few seconds or few minutes to set up our Python installation. Now our setup is successful. Click on close. Come back to VS Code. So now here, if you'll see this extensions box, click on this extensions section and click search for Python here. We need to install Python extension. So the third option, okay, Python by Microsoft, click on it. In my case, now it is already installed. In your case, it might be already installed or not. So if it is not, then you will get one option here to install it. Just click on it and install Python extension into your VS Code, okay? Now, the next part is create one folder into your local PC. In my case, it would be FlowRidge project. If I click on this, then I'll give you generate data Python file with which we will be generating files. And once we generate those files, we will see how we can work on that as into our data pipeline in Snowflake. So that Python file, you need to move it in this folder, okay? Come back to VS Code. I'll close this extension. Now file, open folder, and we will be opening that respective folder which we have just created, okay? I'll open this. I'll just click on this and I'll say select folder. Now, under this folder, we can see that we have this file. Click on this. I'll just minimize these sections, okay? So now this code will generate all of our respective files. So as I have told you earlier, we'll have two modes, historical and continuous. So what I have done for dev environment, I have made separate historical mode and continuous mode. And for prod environment, I have made another command to run historical mode and continuous mode. Okay. So when we need to run our files, we'll just copy these commands and we'll paste it under terminal. Okay. So for that, click on terminal, new terminal, and here you need to paste these commands, okay, as needed and as required. Here you need to make sure that this path, right? This path should be of your folders path where you have created that folders. Otherwise, what happens? Many times what happens is here your path name would be different and you are trying to run that file under this path and it will not be successful and it will keep throwing errors. So for that, make sure that this path is of your folders path. To cross verify, come here and if you click on this path, then this path should be there, okay? Now we'll paste these commands and we'll run it here. Before this, what we need to do, we need to make few changes here because we need to connect this with our ADLS Gen2 account. So for this, we need to enter our connection string and container names here. So for that, now let's move to our Azure storage account. Sorry, Microsoft Azure portal. And here first we will create our resource group. Okay, so search for resource groups. We'll create one resource group for our project. So create new resource group. I'll give name as Lowbridge RS. Select your region, click on next, next, and create. Our resource group is created. Click on refresh. This is our resource group. Click on it. Now under this resource group, we will create our ADLS Gen2. Okay, so click on create. Here search for storage account. This first option, click on it. Click on create. Make sure that your correct resource group has been selected here. Now we need to give our storage account name. So I'll give name as Flowbridge. We can't give underscore. Flowbridge project ADLS. I'll give this name as. Select region, nearest region. Preferred storage type, I'll select Azure Data Lake Storage. Performance standard redundancy, I'll keep it as LRS. Next, here you need to make sure that you are enabling hierarchical namespace in order to maintain subfolders and all the directories like folders within folders. Click on it. Next, rest everything we will keep as it is. So I'll click review plus create directly. It will take some time to validate and create our storage account. Now validation is completed. Click on create. Now deployment is successful. Go to resource. Here under data storage, click on containers. And now we will create two containers, one for dev and one for production. Okay. So add container. Let's give name as supply chain raw and then dev. Again, we will click on add container and now we will create it for production. Again, I'll click on create. Okay. Now these container names you need to give under in VS Code. Okay. So this one I'll copy. If you'll see here under containers in front of dev, give that name. And under production, give production container name. I think it is same only, but still. And make sure that you are giving these names in between inverted commas. Okay. So now we have given our container names. We are left with now connection string. Okay. So for that, again, come back to your storage account. Here under security and networking, you will see access keys here. Okay. So you will get key 1 and key 2. You can use any one of the key. As of now, I'll work on key 1. Okay. Here, this connection string you need to copy. Okay. Not key. It's the connection string which you need to copy. So for that, first click on show. And once it will show your connection string, click on this copy to clipboard. Copy this and then come back to your VS Code. And then I'll just remove the existing one. And in this inverted commas, I'll paste my connection string. And then you need to make sure that you are hitting Control plus save. Otherwise, what will happen? It will keep running these commands under this terminal, right? It will not generate those files under that containers because we haven't saved our recent changes. So make sure that you save your recent changes, then terminal and click new terminal. Okay. So now I'll come back to containers. I'll come back to this dev container, and now what happened? Okay, so let me come back to this again. Storage account, Lowbridge ADLS, okay, containers, supply chain raw dev. Okay, as of now, I don't have any values or any files here. Now we will generate 3 files. If you remember under historical, it should generate 3 files here with 100 records each. So now I have given you all the commands here. Just copy those commands and paste it here and run it. Okay. So now our environment is dev and mode is historical. So this command I'll copy, paste it here and hit enter. Our 3 files has been created for dev mode, dev environment and historical mode. It will give you information about each of the file here. And in summary also it will give you some information. This section expected in Snowflake, we will validate this section when we are working on our ETL pipeline in Snowflake. Okay, so for that sake, this part will be beneficial. Now if I'll come back to my storage account, I'll refresh it. And now we can see that we have these 3 files created under this development container. Now till now we have seen how to configure VS Code, then how to connect VS Code with our ADLS and generate files from VS Code into ADLS. Okay. If you remember under Snowpipe, we need to create storage queue and Azure event grid. So that section we will perform it now. For that, what we will do, I'll come back to these containers under queues. Now we will create one queue here. Okay, as of now we don't have any queues. Click on add queue. We need to give our queue name. Let's say maybe low bridge supply chain queue. I'll click on OK. Now our queue is created. We will move to our events section. Okay, so you need to search events. Okay, here we have events. Click on this. Now we will need to create event subscriptions. So we will create two subscriptions. One will be for dev and another one will be for production. I'll click on event subscription. We need to give our subscription name here. So let's say what we'll do, we'll say flow bridge Snowpipe subscription for dev. Event schema would be our event grade schema. Here you need to give one topic name. Okay, so I'll give my topic name as Flowbridge Snowpipe subscription topic. Then event types, by default it will select 2 types, but as of now we just need blob created, so I'll just deselect blob deleted. Then you need to enter endpoint here. Okay, so endpoint type here will be our storage queue. Select that, then click on configure an endpoint. So here select your respective storage account, and then it will show you existing storage queues. If in case if needed, you can create new storage new queue from here also. As of now, we will select our existing queue which we just created. Click on select. Then come to this next tab, which is filters. Here we are going to enable filter. Okay, so this subscription is for development, so we need to enable this filter for only development container. Okay, so let me open our container names into another tab first. Okay, so this resource group, then containers. Okay, now coming back to our create Azure subscription. So we'll say subject begins with. Okay, here we will enter blob services. S needs to be capital / it starts with slash blob services slash. We will default it to container. So say default slash containers slash, and this dev container name you need to enter there. Okay, so I'll just copy this dev container name. Coming back to subscriptions, I'll paste this and again slash, and then we will click on create. So now this will create event subscription for our development container. Similarly, we will create another one for production. Okay, so I'll just copy this name first. Again, I'll click on event subscription. Name, instead of dev, I'll say prod. Again, same event grid schema. Now you can see all the topic names. It will be shown here. Here we will select blob created. Endpoint type, it would be storage queue. Configure it to our existing storage queue. I'll select that and I'll click on select. Again, filters, we will enable subject filtering. Again, we will say slash blob services slash default slash containers, and here we will give our production container name. And again slash, okay, and I'll click on create. So now in my case, these event subscriptions are getting created because I have registered my subscription. Okay, so you need to make sure, because it might be possibility that while creating these subscription, when you hit create button, you will get one error, topic can't be created, or you are not able to create a topic. Okay, so for that sake, what you need to do, click on your respective subscription. Okay, so subscriptions, select your subscription name. Here under settings, click on resource providers. Okay, under resource providers, search here by event grid. So now if I search by event grid, it will show you Microsoft.event grid, and status here for my case is registered. Okay, in your case, it is highly possible that it would be unregistered. So make sure that you will click on this, and it will give you option to register it. Click on that register option. It will take few minutes to register it, and then again try to create this event subscription after few minutes. It will give you that, sorry, you will be able to create this event subscription. Okay, in my case, I'm able to create because I have already registered it. In your case, first register it and then try to create event subscription again. I'll click on create. Now we are done with our storage queue and event grid subscription creation. Okay, now we will move to our Snowflake section. I'll log into my Snowflake account first. So this is how my snow site looks like. Here we will create first one workspace for our project. Okay, so for this, under projects, now we can see this workspaces option. Okay, click on workspaces. Now under this new changes, right, under Snowflake, you need to create these workspaces. Earlier you used to create worksheets. Now those are like legacy worksheets, and now Snowflake is making so many changes. So this is one of the new change where you can create workspaces. Okay, now this is my previous workspace. Here now we'll create new workspace. Okay, so click on this create workspace, this plus sign. So once you click on this plus sign, we need to create this Git workspace. Okay, now for this workspace creation, we need to first create our Git repository, and those details we will enter here while creating this Git workspace. Okay, now let's move to our Git repository. Now let's create one GitHub repo to create our Git workspace in Snowflake. So for that, come into this repositories tab, click on new, give your repository name here. Then under the description, you can add your description. As of now, I'll just say in progress. We can change this description afterwards too. Choose your visibility. Then if you want, then you can add README. Then we will click on create repository. So this is our repository which we will be using for our project. Now come back to Snowflake. Here click on this plus sign which says create workspace. Then we will have three options. So click on Git workspace. Here we need to give our repository URL. So for that, again come back to GitHub, click on this code, copy this HTTPS URL, again come back to Snowflake, paste this here. Once you give this repository URL to Snowflake, it will automatically take your Snowflake name. And now here, this is my already existing API. But in our case, we need to create one new API. Okay, so for that, click on API integration. Give your API integration name here. Let's do one thing. I'll give in capital Snowflake project Flowbridge API. Then we need to give allowed prefixes. So for that, come to your main profile of GitHub, copy this URL, and that URL, mention it here, and make sure to remove this additional HTTPS and click on create. It states your API has been created, and make sure that respective API is selected here. Okay. Then we have two options, personal access token and public repository. As of now, we will move ahead with personal access token. Then we need to mention database and schema to save our credentials secret. Here you can opt for your database, which will be given by Snowflake. This will be your default database and schema. Otherwise, you can also do one thing. You can first create database and schema from your Snow site, and then that respective particular schema and database which we will be utilizing for this project, you can select that database here too. As of now, I'll just select the default database and schema. Then we need to create one secret. Here you need to give your secret name. I'll say Flowbridge project. Username would be Flowbridge user. And here you need to mention your personal access token. To get this personal access token, again go back to your GitHub, select your profile, settings, then you will get developer settings option here on the left side. Click on that. You will get personal access tokens option here. Click on it. As of now, we will have classic token here. So select that. Again here, generate new token, which will be classic. Then you need to mention one note here. Maybe we'll say Flowbridge project personal access token. Then you need to set your expiration date for personal access token. Then you need to select scope. For this project, as of now, only repo scope is fine. So select that repo scope and then come down and say generate token. This will be our one-time use token. Coming back to our Snowflake. Sorry, I forgot to copy this token. Come back to Snowflake, paste your token here. Then again select database and schema to save your secret. Here again I'll select user one and schema I'll have public, create. And then again I'll click on create to create this workspace from our Git repository. Now let's wait. Okay, our workspace has been created successfully. Now we can see that our repository name that is getting displayed here. If you will select this drop down box, then you will be able to see all the workspaces which you have under this Snowflake account. So as of now, you need to make sure that your correct repository has been selected here. Then if you'll see here, you have file section. So this readme file is from this Git repository. Okay. So whatever you will have here, it will be displayed in this section, or whatever you will create in this section by clicking add new. So if you'll click on add new, you will be able to create new SQL file, Python file, notebook, Streamlit app. Also, you can create it from here. We have folders. If you would like to upload something, then you have option to upload files and folders, and you have option to create dbt project too. So whatever you will create from here, that will get listed down in this section. Okay. And in front of that, you will get written as A or M. A means newly added and M means modified. Okay. So that file has been modified. So it will show you as M. So whatever addition or changes which we will do here, that will get displayed into this changes section. Okay. And from this changes section, you need to push your code to our Git repo. Here, if you'll see, we have branches too. We have, as of now, by default, main branch. Then you can create multiple branches here. We are going to see how we can create that. So it's just the overview purpose. Now, if you'll see, we have this databases option here too. Under this databases, you will be able to see all the databases which you will create or which are already there into your Snowflake. Then under that respective database, what are the schemas which you have? Under those schemas, what are the tables, stages, file formats, pipes, whatever is there, it will get displayed here under databases. Okay. So it will make our navigation easier, and it's always good to have overview what we are creating, what we have created, is that getting reflected correctly or not. So for that purpose, we can use this databases section. Under databases, everything will get displayed under objects. Then we have data products too, which will show if you have any data products under your organization. As of now, we don't have any. So this is how this workspace look like. Whatever you will add here, that file will get open here, and you can run this file from here. Okay. Now what we will do under changes section, we can see that we have main branch here, right? And as we have decided earlier, we will create dev branch and then we will create another feature branches. So now let's click on new, and then our new branch name would be dev. So write it here and then click on create. Okay, so now we can see that instead of main, we have dev branch selected. Okay, now we need to create feature branches. So for that also, you need to make sure that we have selected dev here, because feature branches we are going to create under dev branch. Okay, so if you select main branch here, then the feature branches will get created under that main branch. So make sure that you are selecting dev branch here, and then let's just wait for this first. Okay, we have refresh option here too. Okay, now we have this dev branch. Now we need to create our feature branch. So for that, again, click on this new button. Okay, from here you can see create branch and then from dev. Okay, now we will give our feature branch name here. So our feature branch name would be, let's say, feature slash 01 setup. Okay, then click on create. Now here it will automatically change your branch from dev to feature setup. Okay. Now we are ready to write our code. So come back to files, click on add new, click on SQL file. Now we need to give name to our SQL file. So let's say our SQL file name is 01 account setup. Once you hit enter, now you can see A here. That means this SQL file has been added now. Okay. And this is where we are going to write our SQL code. Now here also you can see that we have this blue dot under changes that indicates that you have some changes under this workspace. Okay. If you will move to here, you can see that those changes will get displayed here. Okay. And then we need to push this to that feature branch. But as of now, let's first write our account setup SQL file and then we will push it to Git. Now let's start writing our setup file. Now we will start with our account setup where we will create databases, schemas, warehouses, and resource monitors. And we are going to run this as account admin. So for this, we need to make sure that we select correct role. Okay. So on the right hand side, you can see that if you select on this, then these are the roles which we have: account, org, public, security, system, and user. And then we have warehouses also: compute, analytics, pipeline. So these are custom one. By default, you have this compute WH and system one. Okay. If you'll select on this choose database, from here also you can choose your respective database. And then if you'll click on that, you can select that respective schema also. But as of now, we don't need to select any database because we will create new database for our project. Okay. So first here, we need to make sure that we have selected account admin role. So you can select it from here also. Otherwise, by using SQL query also, you can use it. Okay. So we can say that use role, and then you need to mention your particular role and then run. I hope it is visible. Okay, so now it states that result will be shown as like this with the status successfully executed. Now we need to create databases. Okay, so for our project, as we have decided earlier, we will be having two environments, right? Dev and prod. So for dev, we will create one database, and for prod, we will create another database. Okay, so we'll say create database. So you can say create database if not exists, or you can say create or replace database. Okay. As of now, we'll say create database if not exists, and our database name would be, let's say, Flowbridge dev db. Okay. You can execute as it is, or optionally you can add comment too. Let's say in comment we'll say Flowbridge supply chain development environment or database, whatever it is. And then we will hit and we will run this query. Now we can see that database this has been successfully created, and automatically that database will get selected here. Okay, if you'll click on this, I don't know why it is not showing it here. I think we'll need to refresh it once. Okay, so now you can see your database which you have created just now, and under this database you will have public schema which will be provided to you by default by the Snowflake when you create that database. Okay, and that will get selected here. So make sure that whatever database we are selecting in our projects going forward for every layer, that gets reflected here correctly. Now similarly we need to create another database for our production. So what I'll do, I'll just copy this code and then paste it here, and instead of dev we'll say prod db, and here I'll change it as production database. Okay, and again I'll run this query and it has been executed successfully. Now here you will see that there is one blue tick here. So whenever you will execute any query, whatever part of that query gets executed, that will get shown as a blue tick here. Okay. Now if you'll see under this databases, we can see our two databases are getting displayed here correctly. Okay. Now here under these databases, you will see two schemas: information schema and public schema. Similarly, it goes for production and DB. So this information schema is for Snowflake management. You can't change or you can add, insert or delete this information schema. but you can add things into public schema. Okay, this is for our practice or our use. Then going forward, now we are done with our databases. Now we need to create our schemas. Okay, so for that, what we will do first, we will create schemas for dev and then we will create schemas for prod. Okay, now to create schemas under dev, we'll say create schema if not exists. Then we will maintain our hierarchy. Okay, so in the hierarchy, first we will have database, and under that database we will have schema. So our database name is this one, and then dot, and then we will give our schema name. So our schema name would be bronze SCH. We will have four schemas here: bronze, silver, gold, and serving. Okay, again, adding comment is optional. You can say maybe raw ingestion layer, and let's execute it. It has been executed successfully, and now we can see that that is getting selected as expected in this section. Okay. Similarly, we are going to create 3 more schemas. So what I'll do, I'll just paste this same query 3 times, and we will make only necessary changes. Okay. Now here replace this bronze with silver, then gold, and then serving, and we need to change our comments. So here we will say transformation layer, then we will say aggregation layer, and then we will say serving layer. And now let's execute rest 3 queries at one time. Okay, so in that case, just select those 3 queries and hit on run button. Okay, so now our queries has been successfully executed. Here on the left hand side under database explorer, you have this refresh button. Click on this refresh button, and now you can see under this dev DB we have our 4 schemas as expected. If I'll open any one of the schema, it will not show anything because we haven't created any objects yet in those schemas. Okay, so as of now we have created schema for our dev database. Similarly, we are going to create for prod database. So that prod database is this one, Flowbridge prod DB. So what I'll do, I'll just copy this code first, we'll paste it here, and then we will make some necessary changes. So now here instead of dev, we'll just say prod. Okay, so make these changes first. Okay, and then all together we will create all this schema by clicking on run. Okay, now hit refresh button, and now we can see all of our schemas are created under our prod DB. Now the next step is to create warehouses. Okay, so we will create 2 warehouses. One would be pipeline warehouse, that we would use to run our Snowpipe, streams, tasks, and dynamic tables. Then we will create another schema for analytics purpose, and that not schema, warehouse, and that warehouse we will use for Streamlit, secure views, and read for the reader account. Okay, now to create our warehouse, we will write our SQL query, and that is create warehouse if not exists, and then you need to mention your warehouse name. Okay, so here what we will say, we will give our warehouse name as Flowbridge pipeline warehouse. Then we need to mention our warehouse size. For practice purpose, extra small would be fine. Then we will say auto suspend after 60 seconds. And then we will add auto resume. We'll say true. We can add comment too. We'll say pipeline workloads, ingestion and transformation. Semicolon, and we'll try to run this query. It's successful. Now you can see under this section role and warehouse, you will see that that respective warehouse has been selected. Now let's create another warehouse for analytics purpose. For this you need to say create warehouse if not exist, or instead of if not exist you can also say that create or replace warehouse. Anything would be fine. And now our warehouse name would be Flowbridge Analytics Warehouse. I'll change the comment. And then I'll run this. Now our another warehouse has been created. Next section is to create resource monitors. We need these monitors to keep track of our credit quota. So for that, what we will do, we'll say create or resource monitor. And our monitor name would be, let's say we will create one resource monitor for one warehouse and another one for analytics warehouse. Okay, one for pipeline and another one for analytics. So let's say Flowbridge pipeline resource monitor. And then we need to assign some credit quota for that. Okay, so let's say with credit quota, let's give 20. Frequency, you can set it. For this we will set frequency as monthly. Then we'll mention start timestamp. We'll say immediately. Then we will mention triggers. Okay, so triggers. First trigger we will create when our 75% quota is completed. That means credit usage is completed. Then we'll say on 75% do notify. Okay, so it will trigger one email to your email account. Then on 90% again do notify. And on 100% usage do suspend, so that it will not keep consuming your credit quotas and wasting your credits for no reason. Click on create. Okay, so it has some credit create, or we need to mention replace resource monitor. Now I'll run this. Spelling mistake. Okay, so now one resource monitor has been created for one warehouse. Then we will create another one. Okay, this resource monitor name would be, let's say, analytics resource monitor. Okay, and then we will run it again. This is also successful. Now we need to assign these monitors to our respective warehouses. So for that, what we can say, we'll need to alter our warehouse. Okay, then we'll say alter warehouse. Which warehouse? Flowbridge pipeline warehouse set resource monitor first, first resource monitor, okay? And then again, we will paste it here, and this one would be for our analytics warehouse, okay? So I'll just replace this resource monitor with analytics resource monitor, and warehouse name, we need to change it to Flowbridge Analytics Warehouse, okay? Just select these two queries and run it. It has been executed successfully. So this is one of the way to create these resource monitors via SQL queries. We can create it from Snowsite also. So for that, see, this is our Snowsite. If I'll come to admin section, click on this admin section. Now, if you'll click on this cost management, under this cost management, you will see multiple options, and this is our resource monitors, okay? So you can see that these two resource monitors which we have created, those are getting displayed here. So from here also, this is we can create these resource monitors. So this is our Snowsite. Under manage section, admin section, cost management, resource monitor, click on this plus resource monitor, and whatever information which we have filled into our SQL query, like name, credit quota which we have set 20, monitor type, we have altered it to our warehouse, right? So that section here. Then we have schedule option, and whatever percentage which we have mentioned, 75, 90, 100, those percentage we can add it here, and we can click on create resource monitor, okay? So this is another way to create our resource monitor. Now coming back to our setup SQL URL, not URL, SQL file. Now our next part is to grant privileges to sysadmin, okay? So whatever we have done here till now, we have done it using account admin. Now we need to grant respective privileges to sysadmin so that we can use that role going forward without any limitations. So now first we need to make sure that we have selected account admin role. Again, I'll say use role account admin. Then first we will grant execute task, okay, on sysadmin. So we'll say grant execute task on account to role sysadmin. Run this. Now we will grant warehouse usage to sysadmin, okay? So now we'll say grant usage on warehouse. So our first warehouse was this one, to role sysadmin. Then again we'll say grant usage on another warehouse, okay? So I'll just paste this, and we will mention our another warehouse here, and we will run this query. Now we need to grant privileges to our databases and schemas, okay? So now again, if we'll go back to our Snowsite, if you'll see on this left hand side, we have this horizon catalog option here, okay? Then here we have catalog option. Under that, we have database explorer. If you'll click on this, you can see your databases and schemas, whatever objects you are creating from Snowsite, okay? So this is what we have created, dev and prod, okay? So if I'll select on this dev, on this right hand side, if you'll see, right now role is account admin, okay? And all the privileges are right now to this role. And now we need to grant our permissions to sysadmin along with this account admin, okay? For that, we are writing our SQL queries to grant usage and all privileges. So that one was one way to create or grant those usages via SQL query. Another option is to select this, and you have this option of transfer ownership. Okay, so if you'll click on this transfer ownership, then it will give you your current owner, and then it will ask you to select another role to which you need to transfer your ownership. Okay, so from here also you can select sysadmin, and once you select sysadmin, you can say transfer. Okay, as of now, I'll click on cancel, but this is also another easier way to grant your ownerships. Now we will see how we can do it with, already we are seeing it, how we can do it with SQL queries. Now let's say grant all privileges on database. We need to mention our database name to role sysadmin. So this SQL query is equal to whatever we have seen from Snowsite about that transfer ownership. Okay. Similarly, we will say grant all privileges to our another database. Now we will run this query. Now statement is executed successfully. Let's come back to our Snowsite and let's just refresh it. Okay, so I needed to refresh whole page. I was not getting that option to refresh, or maybe this one was not working as expected. Now if you see here, earlier there was only account admin privilege with only ownership. Now we have account admin plus sysadmin. Okay, so these privileges we have granted using these SQL queries. Now if you see, now we have granted it to database. Now we need to assign these privileges, or we need to grant these privileges to schemas. Okay, so in Snowflake, these privileges will not get inherited from database to schemas. We need to grant those individually. For that, let's say grant. Let's first open on Snowsite. Okay, let's say we'll open bronze schema under dev, and this is what our current scenario is. Okay, privilege only to account admin. Now coming back to our workspace, we'll say grant all privileges on. Now we can say all schemas in database name to role sysadmin. And similarly, I'll just copy this. We'll paste it here and we'll just change our database name. Okay, here. Now one is for development and another one is for production. And all together, I'll run these two queries. Okay, now statement executed successfully, 5 objects affected. Coming back to Snowsite, let's just refresh this page. Now we can see under privileges, we can see many privileges with account admin as current role, and then we have sysadmin also role here. Okay, so this is how we can cross verify from here. We have edit option from here too, from Snowsite, and it will show you all the privileges here. You can add privileges from here also, and then you can select it and you can say update privileges. Okay, so this is another way or second way from where you can grant those privileges. Now coming back to our file, let's say if you want to verify, okay, whatever we have created has it been created successfully or not. We know that we can check it from this side, this left hand side. We can check it from Snowsite also. We can check it using SQL query also. Like for example, show, let's say databases like, and we'll say under like, we'll say flowbridge underscore percent. So starting with flowbridge, whatever databases are there, that will get shown here. We'll see here, we can see all our two databases which we have created in this project, along with their ownership, when it was created, comments which we have added, retention time. By default, retention time is 1. Databases are standard databases. So all of this information will get displayed here, which you can see via SQL query. Now let's say we need to check warehouses, okay? So just instead of databases, we will say warehouses. We will change this keyword to warehouses. Let's just run this. And we can see two warehouses which we have created that will get shown like this. We can say show resource monitors and run this. So it will show all the resource monitor which you have in this Snowflake account, okay? Out of these, first and last, those were already created, already existing for another purpose. And second and third, we have created for this project. So this is how you can always cross verify whatever you have created. Now we are done with our this account setup. Now it's the time to push our code to GitHub, okay? So for that, again, switch back to workspaces. Now see under this changes option, make sure that your feature branch has been selected here. Click on push, okay? Now we'll write some comment here. Let's say feature 1 setup completed. We'll click on push. Now it will give you one notification as push to Git, okay? Let's just, okay, now it has been completed. Now go back to your Git account. So now if you'll see here, this one was our Git repo. You will see Dev had recent pushes 2 seconds ago. Now click on compare and pull request. So here you need to make sure that by default it will give you base as main and compare with Dev. You need to change both of these, okay? So our base needs to be Dev and we need to compare it with our feature branch. This will make sure that we are pushing our changes from feature to dev. Because if you remember main branch, we are going to use it for production environment. So here, this is the main change which you need to make sure, okay? Now, if you want, you can add description. Otherwise, leave it as it is and click on create pull request. Now it will say no conflicts with base branch and then merge pull request. Confirm merge. Okay, so now our merge has been completed successfully from feature branch to dev branch. Now, if you would like to, then you can delete this branch. If you want to keep all of the history of every pushes, you can keep it as it is. Now, if you'll come back to pull request or maybe to our project, it will keep showing you dev had recent pushes, okay? Let's just refresh this first. Okay, so again it will show you because whatever changes we have done, we have pushed it to dev and what we didn't push it to the main. Okay, so it will keep displaying you this information. You can leave it as it is because all together at the end we are going to push everything to the main branch. It will keep showing you like this. That's fine. After some time it will go. Okay. Now coming back to our Snowflake account. Now we are done with our set first step, okay? Now the second step is to create bronze layer or bronze work. So for this, we will create another feature. Again, make sure that you switch back to dev. Once you switch back to dev, then we will create our another feature branch, okay? These switching branches, okay, it has been switched. Now here dev has been selected, then click on new. Our another branch would be feature 0 to bronze. And make sure that it is displaying from dev here, okay? Create. Okay. Now make sure that our second feature branch has been selected here under changes. Switch back to files. Now we will create our another file. That would be SQL file. And name for this SQL file would be 0 to bronze. Once you hit enter, it will open your SQL file here. And now we will start with our data ingestion part into this bronze file. Now the purpose of this bronze layer is to create storage integrations, file formats, external stages, raw order tables, and to create Snowpipe, okay? So data ingestion part from Azure ADLS Gen2 to Snowflake, that part we will perform here. So first we need to make sure that we are selecting correct environment. That means correct database, because now whatever we are going to do, that will be under our development environment. And once we are done with this development environment, we are going to use zero copy clone to promote everything to production. Okay, so whatever we will do right now, that will be our under development environment. So now let's say, okay, so first we need to make sure that we are selecting our correct database. So our database name is Flowbridge DevDB. Run this and verify from here that you have selected correct database. Okay, then again make sure that you have selected correct role. So let's say use role account admin. Okay, here we can see correct role has been selected. Now we will create our storage integration. Okay, so to create storage integration, let's say create storage integration if not exist, or we can say create or replace storage integration. And we need to give our integration name. Okay, our name would be Flowbridge ADLS integration. Then we need to mention type of our storage integration. So our type is external stage, because we are going to pull our data from Azure. So that is our external, and storage provider would be our Azure. So mention storage provider Azure. Okay. Now we need to enable it. So enabled is equal to true. Then you need to mention Azure tenant ID. So this tenant ID, you will get it from your Azure account. So for that, go back to Azure. Here you need to select Entra ID. Yes, Microsoft Entra ID. And you will see your respective tenant ID here. Okay, so this tenant ID you need to copy. Copy this tenant ID back to Snowflake, and that tenant ID you need to mention it here under inverted commas. Then we need to mention storage allowed locations. You can give single location or multiple locations. So what we will do, we will mention two separate locations, one for dev container and another one for production container. Okay. So for that, we will have curly braces. Here we will give our first one, and then here we will give our second storage. Okay. Now to mention this allowed storages, what we need to do, we need to say Azure, then double slashes, and then we need to mention our ADLS container name. So our ADLS container name was this one, right? Low bridge one. So this container name, copy this, paste it here, and then we need to select dot blob dot core dot windows dot net, and then slash, and from that container name, from that ADLS account, you need to mention that respective container name. So in our case, this is our development container. Okay, so you need to mention that container here, and again slash. Similarly, we need to mention it for production. Okay, so what I'll do, I'll just copy this one, I'll paste it here, and this instead of dev, our account was prod. Okay, so mention it as prod. So these two locations will be allowed from where you can pull those respective files. Okay, and storage provider will be Azure. Now semicolon, and we are going to run this. Okay, run. Okay, it states unexpected at line 19. Now what we will do, we will use Cortex code for this. Okay, so if we'll click on this fix, this is Cortex code provided by Snowflake, officially nicknamed as Coco. So this is very helpful to detect if you have any code issues, or if you have any like normal queries also regarding Snowflake. If we'll give that query here, it gives you correct answer and it is very helpful. Now let's say it is saying that the issue was on line 19 to 22 regarding parenthesis. Okay, so I have given curly braces, so it was simple braces or round brackets, we can say that. So it will automatically show you errors in red bar, and it will also give you correct code with green color. Okay, and we just need to click on keep all, and then it will replace our incorrect code with the correct code. Okay, now let's try to run this. Okay, now it states that integration this has been created successfully. Okay, now you need to run describe command. So we'll say describe integration, and then you need to mention your integration. Okay, integration name. Run this. Now you will get this information. Here you need to click on this Azure consent URL. Okay, this URL. Click on this URL. It will open one another site. Okay, so in my case, I have done this integration many times for another projects. That's why it didn't show me any pop-up. But in your case, it will give you one window here, small window, where you will say you will need to click on allow. And once you click on allow, then it will give you this site. This site is of no use, but it will show you that it will give you, or this is the consent URL, which will allow you once it will give you that respective permission to access that Azure. Okay, so it is mandatory or it is necessary to click on this URL in order to get that consent. Then This part is important, and after that, this Azure multi-tenant app name is important. Okay. So if you'll click on this property value of app name, just double click on this, it will give you value here. Okay. So you need to copy this value. Then you need to go back to your Azure account. Then we need to go to access control. Here we need to assign that, we need to perform role assignment. Okay, so click on add role assignment. Here search for storage blob data reader. We can give contributor also, but it is not necessary. Only storage blob data reader is fine as long as this project is concerned. So click on this storage blob data reader, click on next. So assign access to user group or service principal, click on members, select members, and then paste this multi-tenant app name, okay, here. So it will not give you anything. Just remove this portion. Okay. Now it will give you that application name here. So whatever it was there after underscore, that underscore plus afterwards value, that we need to remove. First section, first part, we need to copy it here. Then that application name will get displayed here. Click on that application, select, click on review plus assign, and that role assignment will get completed to that respective application from our ADLS Gen2. Okay. Again, click on assign. Now it will say add role assignment completed. Role has been added successfully. Okay. So these two things are very important, 7th and 8th, in order to consent your URL and assign application permissions to our ADLS account. Now we need to grant our usage to sysadmin. Okay, as of now everything is for account admin. Now we need to grant it to sysadmin. So we'll say grant usage on integration. We need to mention our integration name here. This one was our integration name. We need to mention that here. To role sysadmin. Hit enter, hit run button. Successfully executed. Now we need to set our notification integration. Okay, so this part was for storage integration. Then the next part is to set our notification integration. Okay, and this part we have done it already, because in this we need to set our event grid and storage queue from Azure, and we have seen it earlier and we have set it earlier. So that part comes here. Okay, step 1 to create storage queue, and then step 2 create event grid subscription. Okay. Now, okay, so we have forgotten one part. We need to set notification integration, and for that, beforehand, we need to set this event grid and storage queue. Okay, so which we have done in the earlier part. Now, to set our notification integration, we'll say create or replace. Okay, so we need account admin role only for this. Okay, so create or replace notification integration, and we need to mention our integration name. Okay, so let's say our name is Flowbridge Azure notifications int. Then we will give object properties as enabled equal to true. Then we need to mention type. Type will be our storage queues. Okay, queue. Then notification provider. Our notification provider is our Azure storage queue. Okay. Then we need to mention Azure storage queue primary URI, and that URL you will get it from Azure account. So for that, go to queues, this queue. Okay. In front of that, you will get that URL. You need to copy this URL and you need to paste this URL here. Once we give this URL, we need to mention our Azure tenant ID. If you remember, we have already seen our Azure tenant ID, which we gave here to create our storage integration. So same thing we will copy from here. Then we will mention that tenant ID under inverted commas and semicolon. We will run this notification integration creation. It has been created successfully. Now, again, we will say describe integration and then integration name. And this integration name is for notification integration. Okay. First one we did for storage and then the second one is for notification. Now, if you'll see here, we have this multi-tenant app name. Okay. Same thing we need to do. First run this consent URL. Okay. Fourth one, Azure consent URL. Click on this. It will load another tab. Okay. So if you get this display, that means that it has given consent to our URL. Then next, again, multi-tenant app. Double click on this property value. Copy this first section. Go back to your Azure. Again, go back to access control. Add role assignment. And now we need to assign new role, which will be storage queue data contributor. Search for storage queue data contributor. Select this. Next, keep access to users. Select members. Paste that app name here. It will list down your application. Click on that. Select review plus assign. Again, click on review plus assign. Our role has been added successfully. Okay. Coming back to Snowflake. Now, again, we need to grant to sysadmin. So we'll say grant usage on integration. Then this integration name. To role sysadmin. Run this. It is successful. Now we need to switch to sysadmin. Okay. So make sure to use role sysadmin. Earlier, whatever we have done, we need to make sure that we are doing it with account admin. Use role sysadmin. If you'd like to check what are these roles, what's the difference between these all the roles, then simply search on the Google. It will give you all the information which is required and needed to know you. It's pretty simple, so you can do it by your own also. Use role, then use database. Now we need to make sure that our database is this one. Okay. You can do it by SQL queries. From here also you can select and change those. Okay. Now use database, use role, then use schema. Our schema would be, so let's give database dot schema name, and then our warehouse. we need to select, which would be Flowbridge Pipeline Warehouse. And we will run all these queries all together. So everything is successful. Role has been changed, warehouse has been changed, database and schema has been changed. Now the next part is to create file format. And our file format is JSON one. Okay. So we need to we need to create JSON file format in order to, like, now our data is coming from Azure storage to Snowflake via Snowpipe. But once it arrives into Snowflake, we need to mention some data, we need to assign some file format for that, right? In order to get that data correctly. So let's say create file format. If not exists, we will create this file format under our bronze schema. So we'll give bronze schema dot JSON file format. We need to mention type of our file format, which is JSON. We need to mention it into inverted commas. Then we'll say strip outer array true. This statement, what it will do, it will unwrap the outer brackets, okay, so that each element becomes a row. So these brackets, it will unwrap. Now again comment optional thing. We'll see. And then we will run this file format. Okay, so it has been created. Now let's say describe file format and format name. Now see, these are our objects, right? Object properties which we have assigned for this file format. But let's say if in case you don't know which properties you need to assign. So in that case, what you do, just create that file format with type, then run describe file format, okay? And it will give you all the properties. What are their respective property types? What are their values? And what's the default one, okay? So all these object parameters, you can check it from here. Now, let's say I have forgotten to give any of the object parameter, right? Then after describe, I got to know that, okay, I need to mention null if parameter here, which I have forgotten. So what you can do after that, you can say alter file format, set value, and that respective property, set property, whichever you would like to give from here, you can assign that property. So this is another easier way because it's not easy to remember each and every object parameters. Okay, so this is the another way and easier way to remember, just to describe file format. Pick all the properties which you need to set again and just do alter file format. Now we have created our file format. Just go back to Snow site. Okay, refresh it. Now we can see that under dev database bronze schema, we can see file formats object here. Under file formats, we can see this is the file format which we have created. If you will click on this, it will give you all the details. Type, compression method is auto, it is by default. Allow duplicate false. Strip outer array which we have set is true. This null values we haven't set it. You can set it to true if you need. Privileges, again you can see it is showing sysadmin also. So this is how you can check all of the information from Snowsite also. Now coming back to our SQL file. Our next step is to create now external stage. Okay, so this external stage will point out to our ADLS storage accounts. So it will not store whatever data is coming physically into our Snowflake. It will just point out to that ADLS account. Okay, So we can refer this external stage and we can check all the information which we store into external cloud storages. So we are using here external cloud storage. That's why we need to create external stage. Okay. We have other options also to create these stages, but for our project, external stage is needed. Now to create this stage, let's say create stage if not exist. We will create this stage under bronze schema. Our stage name would be ADLS raw stage. Then for external stage, we need to mention URL. Okay. Here you need to, for the development, you need to mention URL for our dev container. Okay. So if you'll come up, we have mentioned here location. So this same one for dev, I'll copy and then same we will paste it here. URL, we'll mention that URL. Then we need to mention storage integration. Our storage integration name was this one. Copy this storage integration name, mention that here. Then we need to mention file format, which we have created. Our file format name was this one, JSON file format. And then we can add comment. We'll say external stage ADLS Gen2 dev container semicolon, and we'll run this statement to create our stage. To cross verify, you can again come back to Snow site, refresh this. Now you can see we have new object created named as stages. Click on it. You can see your external stage which is created here. Once you click on this, it will ask you to enable directory. Click on enable directory table. And now here you can see all these three JSON files which we have gotten under dev container in Azure. So if you'll see here, these three files which we have ingested from VS Code by connecting VS Code to ADLS Gen2, these are those three files. If you'll see last three digits, 7389499 and 835. If we'll come back to Snow site, the same files we can see it here, 7389499 and 835. Now coming back to file, let's say if you would like to check it via SQL query, then we can list it down from the stages. Okay. So we'll say list at the rate we need to refer our external stage or to check whatever we have into our external stage. Okay. So let's say we'll say list and then we need to mention this stage name. And we will run this query. So the same thing it will get displayed here. If you can see all these files 835, 945 and 738. These files we can see it by using list command also. Now we will create one transient table raw orders. So till now we have seen or we have done whatever was needed to create Snowpipe. Once we create the Snowpipe, we know that we are going to load these JSON files data into Snowflake, and into Snowflake we are going to need one table. Okay. So to store those data into table, we will create one transient table named as raw orders. For that, we'll say create or replace. Here we need to mention transient table and then table name. We will create this table name under bronze schema. So bronze SCH and our table name would be raw orders. Then similarly, like the SQL query which we write, it's exactly same. We need to mention column names. So first column name would be raw data, and type would be variant because it is JSON. Then along with our data, we will mention few metadata also, like ingested at, file name, file row number, and load ID. Ingested at data type would be timestamp NTZ. NTZ stands for no time zone, and we will default it to current timestamp, comma. Then we'll need file name. So these file names, those will get displayed into that column, because once we insert that data, we need to know that from which file it has arrived. Otherwise, it would be very difficult to check that one data into several files. So for that, we need to maintain this metadata. It would be into string format. Then we'll have file row number, data type, and then we'll have load ID. And we will default this load ID with UUID string. And then if needed, you can add comment. I'll say bronze layer raw JSON supply chain orders for flow bridge and semicolon. It has been created. Refresh this. Under raw orders, we can see that as of now we don't have anything. Let's just refresh it clearly. Okay. Columns, table details, columns, data preview, we don't have anything yet because we haven't fetched that data by creating our Snowpipe. And once we load that once we load that data from Snowpipe, then we will be able to see our copy history here. Okay. We'll see first how we can create that Snowpipe. We'll fetch that data and then again we'll verify that table. Now we need to create our Snowpipe that will auto-ingest our data and will get triggered by our Azure event grid on file arrival. For that, we'll say create, or we can say create pipe, or we can say create pipe if not exist. We will create it under bronze schema. Make sure to add that schema, and our pipe name would be supply chain pipe. Then we will give object properties as we need to turn on auto ingestion, right? So we'll say auto ingest need to be true. Then we need to mention our integration, which would be our notification integration of storage queue. If we'll go up, this one was our notification integration. Copy this, paste it here, comment. Okay, so this section will create pipe, but while creating that pipe, we need to perform data movement, right? So for that, we'll say copy into this pipe, will fetch that data and then it will copy that data into this raw orders. Copy into raw orders. In order to maintain our column mapping correctly, we will mention our 3 column names correctly, which will be raw data, file name, and file row number. Rest two columns, ingested at and load ID has been defaulted to current timestamp and UUID string. So that is not necessary to add it here. Copy into our transient table from Snowflake, and we need to copy this from external stage, which is referring to our ADLS account. Now to query external stage, we can't have select star from, or we can't mention select column names from. So for that, what we need to do, let's just first write select from. We need to mention our external stage by @. We will mention our external stage name. And then while pulling this data, we need to make sure that we have assigned correct file format. So file format would be equal to, and then we need to mention file format which we have created earlier. So for that, we need to mention format name, and then we'll give format name in this inverted commas. So our format name, nothing but file format name, was this one. I'll just copy this and I'll mention it here, and then semicolon. Create pipe with these parameters as copy our data from this external stage into our transient table. Okay. Now here we need to mention what we need to copy. Select. In order to refer columns from external stages, we need to mention $sign. Okay. $1, that would be our first column. Then $2, that would be our second column. So our first column would be of raw data that will get referred by $1. Then we have mentioned some metadata too, right? So to refer that metadata, we need to mention metadata key by dollar, and then we need to mention file name. Similarly, again, metadata $, file row number, and then again metadata dollar. I think that's it. If you'll see, we are mapping this first $1 column with column raw data from raw orders. Then this metadata file name would go into this column, and this metadata file row number would go into this column. And along with these three columns, we have two more columns, and those are ingested at and load ID. And those will get populated automatically. So this is how we can create pipe with auto ingestion on and copying data from stage to our table using correct file format. Now we will quickly run this. Our pipe has been created successfully. Let's cross verify it via Snow site. If I have when I refreshed it, I can see that here we have one more object named as pipes. Name is supply chain pipe. Here under the graph, you can check we have this pipe which is pulling data from raw stage, ADLS raw stage, which is our external stage, and it is pushing that data to our raw orders, which is under this bronze schema. Warehouse, it is by default serverless. Integration, which we have used, notification integration, that will get displayed here. Copy history, no copies yet because we haven't run this pipeline yet. Coming back to SQL. Now we will perform some verification. Okay. Let's say we have seen our pipe via Snowpipe, right? By using SQL, we can say show pipes. And then it will show all the pipes which we have created under this database and schema. Okay. Then we can check pipeline status also. So to check that pipeline status, we need to say select system $sign pipe status, and then we need to mention our pipe name, Snowpipe name, for which we need to check the status. Okay, so our Snowpipe name is this one. We will mention this name here. run it. Now we can see execution state is running, pipeline count is 0. Okay. Now let's alter our pipeline and refresh it. Do it here. We are going to refresh our pipe because our 3 files, those are landed before Snowpipe was created. Okay, so event grid eventually missed them. So we are manually refreshing it so that we will pull all these 3 files from Azure into Snowflake again. Okay, so alter pipe name. We need to mention pipe name. Then simply say refresh. So it will pull that data again. Now see, it shows our files with status sent. Now we will check our raw orders table. Okay, so let's say select star from, and then we will mention our raw orders table. Now you can see we have all of our data and the mapping which we have done. Raw data files, all the data has been gone, JSON files has been gone into raw data. Ingested at, it has taken our current timestamp. File name, it has taken it correctly. 738, then 949 and so on. And file row number, it is also there. Unique load ID also has been assigned here. If you would like to check it from Snowpipe or Snowsite, now let's refresh it. Now here under the pipes, if you'll check copy history, it will show you copy history. Okay. Right now we have performed refresh on our pipe, right? So that history will get shown here. So all these 3 files with their sizes, how many rows are there, what's the status, when it was loaded, that everything will get shown under this copy history. If we'll go to raw orders table, then data preview, we can see 100 of 300 rows, as in total 300 rows has been copied here. Copy history, again it will show copy history to all of these 3 files. Okay, with each of the rows status loaded and pipe name also. Then coming back to SQL, now let's say we need to check ingestion history, right? From Snowsite we have seen it how to check it via SQL query. What we can do, we'll say select star from table. So all this information of copy history that gets stored under information schema. Okay, so we'll say information schema dot under information schema we have one table named as copy history. Under copy history we need to mention table name, otherwise it will give many entries and would be difficult to figure it out. And then we'll mention our respective table name for which we need to check our history, copy history. And along with that, again, for the table, it would give various, so many histories since the start, right? So just to check for particular time or for current runs, we'll say start time would be date add, and it would be into hours -1 to current timestamp, as in since the current time to within last 1 hour, I need to fetch copy history of this table raw orders. Let's run this ingestion history. It states at line 176. Okay, so now we can see that we have three copy histories. As you know, we have three files. That three files history is getting shown here. What was the stage location, last load time, row count, and every information. So basically, point here is to show you this table, copy history, which is default table managed by Snowflake under information schema. You just need to give table name, and for easier understanding and better readability, or what we can say, for the easier understanding, give start time and check that respective timestamp, and you will get all the ingestion history. Now we are done with our bronze layer. We need to push this layer into GitHub now. Okay, then again we can see we have added here. Go to changes section, make sure feature 2 is selected. We will push it. Under commit we will write one message as fit as in feature bronze layer, storage integration, notification integration, raw orders, and Snowpipe. Click on push. It is taking some time. Push is successful. We'll go to GitHub. They've had recent changes. Let's just refresh it once. Okay. It has recent pushes 90 seconds ago, feature 2. Compare and pull. Again, make sure to change base from main to dev. Create pull request. Merge pull request. Click on confirm merge. Our branch has been merged successfully from feature to dev. Coming back to our main repo, we will keep dev changes as it is, will not pull it. Coming back to our Snowflake, now we need to work on our silver layer. For that, we will again create another feature branch. Again, make sure to select dev. It always takes time to switch branches. Okay, now we'll add new feature here, new branch here, new branch from dev. We will give our branch name as, let's say, feature 04 silver stage 1, and we will create it. Make sure that new feature branch is selected here. Coming back to files, add new file, SQL file. Our file name would be 03 silver stage 1. Now we will start with our data cleaning and data transformation part. This is everything we are covering today. In the next part, tomorrow, we will continue building on top of what we have done today. So make sure that you have completed all the steps before moving forward. If you have found this helpful, then please like and subscribe, and see you in the next one.